right, so this week we're going to be talking about Firebase, but make sure you guys go to website, uh, hit the attendance join button. Good question. dsuprog.club. You can go there, do attendance, click meetings, click join. I'm pretty sure I made it go live, right? All right, cool. So Firebase is, what does my next slide look like? Perfect. It's what is Firebase. So Firebase is a cloud platform created by Google. If you've seen commercials for AWS, it's kind of like that. It's not AWS. It's not as powerful as AWS, but it's easier to work with. So Firebase, they provide different API methods and stuff to do a database, user authentication, storage. I think those are the three main APIs. And then they also provide an environment to run like server-side functions. So if you have to do more complex stuff with data, say a user signs up and then you want to send them an email that says like, welcome to my website, you would do that in like that back the server-side functions part. And then Firebase is also the backend that we have our website running on. So there's a couple points tonight. I'm just going to show some of the code we used on it, like showing like this is exactly how we did it. We used Firebase. And then later tonight, probably I'll make our GitHub repo public for our website and we'll put it on the website in our resources. It's a bit confusing because we used a JavaScript framework for the front end and we had to use a different package to make Firebase work a bit better. But the general idea of it is still there. So if you want to go look at it, you can. Why we use Firebase, it's really easy to learn. The docs that Google has are really, really good. There's a lot of projects where the documentation is kind of bad, but Firebase docs are really good. So it's easy to learn and work with. The one thing that we like is it provides free hosting, free SSL, so free HTTPS instead of just HTTP. And it gives you a free domain. It's a subdomain, so it'd be like myprojectname.web.app. So you can run an entire project completely for free because their free tier is super nice. I think you get 50,000 reads from the database per day. So, and then it's like 25,000 writes and like 10 gigs of a bunch of other stuff. It's really generous free tier stuff, so that's why we use it. So when you want to do a Firebase project, I'm just going to cover this super loosely. You'll need to have Node installed on your computer. You just do that at their website. We're not going to have to do that tonight, so don't worry about it. But you do Node, and then you need to Node installs npm, which is a package manager, basically so that you can go and download big projects and libraries that other people have written that do super cool stuff so that you don't have to like rewrite it. So you'll have to install that. And then another thing I'm not going to cover in depth, it's just good to kind of understand, is promises. So JavaScript is an event-based language apparently is what I put there. Typo. So what it means is code necessarily doesn't run in order like it would in C or C++. So when you do an API call and you have to make a request over the network and then the server has to send data back to the client, it can cause some data issues. So in these examples in that C and C++ one, say I'm getting a number from a server somewhere, so I make this API call and set it equal to my variable. That will run, it'll go make the request, come back, set players, and then when I print it, it'll work. In JavaScript, however, this code below there, if I do the same exact thing, it won't wait for the API to come back. It'll just go hit that, it'll just print it, so players will be undefined right there when I print. So what you do is, a common thing is promises. Basically, what you're saying is that API function, it promises that it's going to get data. JavaScript just has to be a little bit patient. So it allows you to specify that it has to wait a little bit, but once this API request or whatever is done, then I need you to execute this code. So I have a really simple example here. So I do the same function call, but then I tell it to do a .then, which is so get the players and then run this function. So I have my function in here. Data is my parameter that's getting back from the server, and then when I print it, That should say data, not players. That's a typo there. But then when I print data inside of that promise, it'll work. Another way you can kind of do it, and this works if you need to save that variable and do it somewhere else, is I would have my API function, it'd be an async function, and then I just say data equals get players, but I have to wait for it, and then it'll print. So just to work with APIs, it's a bit different. So what you would do to make a project is you'd go to their website, console.firebase.google.com, click Make a Project, name it whatever you want. Then there's a project ID, that's the subdomain. So if you want to be able to go to it without buying a domain and not have it be like my project 3469, you want to change that to something that's like pronounceable. But now into the actual meat of Firebase. So the first thing is Firestore, which is their database. Firestore is no SQL, so it's not like SQL classes if you've taken those where you do like select all from table where users equals 1 or whatever. So their API methods, they give you a bunch of ways to read data, to write data, update data, and you can also, so you can either read data or you can basically open up like a listener. So it'll pull data, but then if the database changes, it your connection recognizes it and pulls in the new data. Which is how, for example, when you guys submit a question, it gets put into our questions, and then we have on our end a snapshot is what it's called. That's listening for updates in the questions. So when a new question gets written to the database, it just pulls down the new question and we see it right away. It's also how like meetings we handle live and stuff. So Firebase Store, they're made up of a document and a collection. So you can think of a document as a column in a SQL table. So in an SQL table, you have your, I think that's a row, it should be a row. But so columns, you have name, say name, user ID, email, and then your rows is what a document would be like. So user ID 1, John Smith at gmail.com, that would be a document. And then collections are like a table. So a collection has a bunch of documents in it because the collection is like the table of the users, if that hopefully makes sense. But neat things, since it's no SQL, obviously it doesn't work like SQL. Documents can have different data in them. So say you don't want everything to have a like name field. You don't have to specify that you want the name to be null. You just don't include name. It works fine. You don't get an error like missing column or something like that. And then you just have to kind of remember how you're structuring that document because it can be whatever you want. So here is a picture. This is just a screenshot from the console from our website. So you'll notice there on the left is the meetings. That is a collection. We have like 4 different collections. Then all of those IDs are different meetings. And then the one selected, that object on the right, that is one document of a meeting. I think it's this meeting. So you can see how we have a string field, an array of attendance, the date, which is an actual date, not a string, then another string, a Boolean, and then some more strings. You could include numbers. So types can obviously be mismatched. I thought I put this in a slide, but so basically documents, you can write them like a JSON object is what they pretty much are. So an example. So these first 3 lines are kind of how you just declare them as constants. So DB is how you usually declare like this references my Firestore instance. Then collection ref is a reference to my collection, cities, for example. And then Q is getting ready to do a query on that collection ref. A thing to note, most of my slides are going to be in Firebase version 9, which they just released. But when we wrote our website, it was on version 8, and the syntax is a bit different. So version 9, it's all functional, like there's more function calling. And then version 8, where some of my website code will be, it's like a bunch of like dot do this, dot do this, dot do this. You'll see how it works, but just a side note. So then this function right here, this would be just reading data one time. So I have my get docs function call, so it's getting all the documents from that collection, and then it's .then, so once that data gets back, I'm just printing them all out. But then if I do it like this, I'm using an onSnapshot function. This would be listening for real-time updates. So it prints all of the cities in an array, but then when new cities show up, it pulls all the new cities and prints out what that new collection is. So this right here, that first line, or I thought I changed those to be. So lines 1 to 5, straight up I copied from the website, our website. So we have our database and then the collection meetings. So this is how you can do more complicated stuff, because sometimes you don't want to read everything because that's just way too messy. So here we're getting all of the public meetings, and then we're ordering them by the date. And then, so that's how I did it in our version 8. So then in version 9, you would just do it like this. You'd have your query, collection, do it where this, where that, order by this. You would just do it in commas in a query. And then writing data, so I made my object. You do basically the same thing, just backwards. You can set IDs manually or automatically. We don't bother with IDs because usually you don't care what they are. But you can do both. The Firestore provides that option. So if I have, I can either add doc or set doc. Setting it would be setting one where I manually set the ID, which is why I need that extra doc ref so it knows what ID I'm setting. And then adding it just puts it in there. It assigns some random ID of letters and numbers, and then there you go. So another super convenient I should ask, any questions on like Firestore or Firebase that I've talked about yet? All right, so authentication, dealing with users and passwords and emails and stuff, super duper annoying. Speaking from experience from a project I've been working on where we had to design our own authentication system. It sucks. So Firebase conveniently can do that for you. So you don't have to have a separate collection that's all of your users with like a hashed password and their email and keeping track of that. They have their own separate space to store user information. There's easy API methods. You just say user.signin with email and password, send it the email and the password. It logs them in, handles all of the cookies and stuff in the browser. And then you can also add other login providers super easily instead of just email and password. So here's another example. Here are a bunch of the providers that you can use. This is again from our website. All we had to do to enable Google Authentication was turn it on, mostly because Google wrote it. But we didn't have to add any app secrets or learn OAuth or anything like that. We just turned it on and then it worked. So pretty easy, way easier than doing other stuff. And then they store the passwords in their own probably very complicated Google hashing algorithm or whatever. You don't even have to worry about it. So all you do is you declare your authentication variable, get auth, and then on auth state changed. And this fires whenever it recognizes that something has changed in the user. So if the user object exists, that means they are logged in so you can do something with them. Otherwise, it means there's not a user logged in right now. So you can that either means like if the user is logged in, then up in the corner you can display a logout button. But if they're not logged in, then you obviously don't need to show that, so you just don't. So this is, again, straight from our website. So auth.onStateChanged. So if the user exists, this is when you guys click the Join Meeting button. This runs to add you to our attendance. So if you're there, we add you into the array. And if you're not there, we just call this auth.signin with redirect. And that's all we have to do to pass you off to Google to handle your sign-in. We just say, hey, sign in with Google, and then it does. It just redirects you to Google, you log in, then Google redirects you back to the page you need to go to. So that control flow required basically no work, and it's very convenient. Any questions on that? A thing to note, I guess, if you really want to do it easily, when you're working on the website, they have pre-made authentication like forms. You just have to like include a couple files like with a JavaScript source tag, and then it just does everything for you. You don't even have to write the fields like email and username. It just does all of it if you really want to. So then storage is, there's some API calls. I'm not going to cover them because there's definitely projects where it's useful, but there aren't super a lot of them. But it would be, say, like where if you made like a video hosting website, storage is where you would put all of the videos, and then in Firestore you would have your documents just reference the path to where the video is. So that's what storage is. It's to store things, which is what, so dynamic user storage would be users upload content. Static files is how we use it. When we include images in our presentations, we upload them into Firebase storage just from the console, and then it gives us a link that we can paste in the presentation and just load it that way. So yeah, we don't use this really at all for the website, but the images that I had earlier on in this presentation, they're in Firebase. And then hosting, if you're doing a website, you don't need API methods for this. You just like basically click, I want to host it, and then you deploy it, and then it's hosted. You don't have to do like any setup or anything like that, but I figured I'd mention it because it's one of the super awesome things about Firebase is hosting usually isn't free, but Firebase it is. So why we recommend using Firebase. You can build cool project ideas without giving anybody money. That is the biggest selling point in my mind. I know I wanted to make a project. Everywhere I wanted to do it, I needed to host it, so I just wrote it myself, put it on Firebase, and now I just have a project that I use frequently, kind of. You can use it to prototype an idea quickly. Say, like in your future, if you go like freelance or something, somebody's like, hey, can you build this? You could build a super quick demo in Firebase and say, here's like what it would kind of work. Then you could move to another platform or something. It can expand your skills working with a NoSQL database and how APIs work and stuff like that. I'll click on that link later. This is their free tier, like all the stuff you can do. And even though I covered this in JavaScript, you don't have to use it for a web app. You can use it for a bunch of stuff. Let's see, I think Kotlin is Android programming for like an Android app, similar with Java. Swift is iOS apps, C++, Python, C#, Unity. So you don't have to be limited to web app. Like the functions I showed today, it'd be a little bit different, but the basic concept of collections and documents, that would remain the same. So I'm going to click on this. Wow, that's tiny. So yep, you get basically free authentication. They limit you. You can only have like basically thousands of people sign up in a month, which is fine. You can store 1 gigabyte of data in Firestore, and then a bunch of network input and output, and then, yep, 20,000 writes a day, 50,000 reads a day, 20,000 deletes a day. Cloud Functions isn't really free. I didn't cover that at all today, but it's free-ish. It's the most expensive option, but you can still use them for free as long as you don't do it a lot. Hosting, you have 10 gigabytes of files, and you can do 360 megabytes a day, which sounds like a lot, but we've never run into any problems. Right, Blake? You've never been charged for the Programming Club website? Yeah, didn't think so. So, yes, I have to go back to, do I have that open? Of course not. There we go. All right, anybody have any questions? I know that was probably very fast, but it's a very useful thing just to be able to build projects, because the most annoying part about wanting to build a project is having to give people money, at least in my opinion. So being able to do a cool project for free with a powerful tool like this, super useful. Who's talking next week? About what?
I think it's my turn. And it's a mystery, a secret presentation. That's definitely been planned.
For sure. So I guess then that'd be the end. And again, if you guys have any questions about Firebase, just ask anytime. I mean, I don't respond very well on Slack, but I will. Same on Discord. I'm in the Help Night server. Nick and Nick are too. But yeah. Yeah, we also always go to Help Night. So there we go. You guys all have a good night, I guess. Do homework.